Hello, and welcome to Astronomy 100. In this section, we're going to focus our attention on the concept of galaxies. A galaxy, by definition, is just a very, very large collection of stars. And what we now know, based on discoveries that occurred in the 19th and 20th century, that our sun and our solar system is one of many, many stars inside of this very vast collection of stars called a galaxy. So the sun belongs to one of the many galaxies of our universe. What we also know is that our universe is essentially a place of many galaxies. The galaxies themselves are the largest structures that you could have when it comes to the gatherings of individual stars. But what we'll find out eventually is that you can also have very large gatherings of galaxies as well. So let's go ahead and get started. In this first image here, what I'd like you to know is that this is an image taken by the Hubble Space Telescope. And you can see it's actually quite an amazing image because everything that you see, with the exception of a very few things, just about everything in this picture is a galaxy. This is a star. This is also a star. But all the other objects, even the very faint little smudges that you see here, are galaxies in our universe. So you can see that it is essentially a universe full of galaxies, and the information about the details of each of these galaxies will be the focus of our attention in this section. But let's start with a little bit of historical context. The Milky Way is an object that is essentially one single thing, but when you see it in the sky, will look like it's displayed across the sky, and it'll look like it's multiple things. The image that you see here on the screen is a photo that somebody took of the typical view of the Milky Way as you see it in the sky. And the best time of year to see the Milky Way is during the summertime, and I'll tell you why as we go through this material. But the Milky Way stretches across the sky from horizon to horizon, and it looks like just sort of like a milky white band that crosses the sky. And that's essentially where the name came from. Thousands of years ago, the ancient Greeks really didn't know what it was, but they described it based on its appearance. It does look like a milky path across the sky, a milky white path, or a Milky Way. But if you recall from a previous lecture, it was actually Galileo, with his newly created telescope, where he was able to discover that the Milky Way is a vast collection of stars. If you were to see this with the naked eye, it would look like a milky white band that crosses the sky. But through a telescope, each of these spots that look like they're just sort of a ghostly milky white are actually countless numbers of stars. So Galileo discovers that the Milky Way is really a very big grouping of stars, but really can't figure out much more than that. One of the big questions that came along historically is, what is the shape of this thing that we see in the sky? And of course, where are we located within it? So if you make the assumption that we are inside of the Milky Way, which is a fairly simple assumption to make, what you'll notice is that it does have some details related to the shape that you see. This is a really neat image here. This is what we call an all-sky image. And what they have done is they have taken pictures of various parts of the sky and stitched it all together as one single picture. So if you were to take this edge of the photo right here and wrap it around and attach it to this edge, essentially it goes all the way around you. This is the entire Milky Way. All the way where we leave here is where we would start again over here. So it is clear that there is a big collection of stars that we see displayed all around us. One of the questions, of course, as you see on the top of the screen, is what is the shape of this thing that we belong to? And you might say that this is a simple question to answer. Why don't we just get outside of it and take an image of it to see what it looks like, to see its shape? Well, of course, the problem is, historically, is that there was no way to leave the surface of the Earth, much less to leave the galaxy that we belong to. So leaving the Earth to get out of this thing we belong to take a picture was just not an option. So one way to do this was a method that was employed by William Herschel. In the 1780s, William Herschel was one of the more famous astronomers of his day, employed a technique where he counted stars. So his theory was that if you look in various directions throughout the sky, and if you count lots and lots of stars, you must be looking very deep into this thing that we belong to. And if you count less stars, you must not be able to see very deep into it. So here is an actual drawing that he created where the stars themselves represent the count that he made, looking in all different directions. And here is the location of us. So this is the Earth, this is where we are. And if you look in this direction, he counts lots and lots of stars, which implies that you can see very deep into whatever this thing, the shape of this thing is that we belong to. And if you look in this direction, you don't count as many stars, and if you look in this direction. So essentially, by counting stars and looking in various locations in the sky, he was hoping to try to piece together what the Milky Way would look like from the outside if you could go outside of it to see it. Now, one of the problems is that William Herschel did not know that these dark areas that we see here are actually vast clouds of dust. And the problem with interstellar dust is that it blocks the light from stars that would normally be behind it. So this dark area here is actually not a lack of stars, it is the presence of dust. And so if you're counting stars in this direction, you won't see very many, but if you're counting stars in this direction, you will see a lot of them. So not understanding the concept of interstellar dust, it led him to make an object shape based on star counts that's just wrong. So the size of our galaxy is not this small, and the shape of it is not this shape. So it was a bit of a failure. It was a good idea at the time, but based on information he didn't have, it was something that just didn't work out too well. So counting stars will not allow us to understand the shape of our galaxy. There are other ways to do it, though. Here is the exact same all sky image, essentially the entire sky once again, but this is an image taken by a telescope that can see in the infrared. And so when you look at infrared light, you're seeing light that can penetrate through dust in most cases. Most wavelengths of infrared light can go right through the dust, and the dust now is no longer a problem. Now, what I want you to notice is there's a revealed shape that starts to become apparent. You notice that there's a very, very bright center, and then of course you have a tapering off on either side, and you'll notice, remember, this on this side wraps all the way around to begin on here, so it wraps all the way around you. These two things down here are two neighboring galaxies, something that we'll talk about in another video. So you'll notice the shape, broad in the middle and then tapering off to either side, but having a fairly thick shape to it all the way around. So this starts to give you a clue as to what our galaxy's shape might be from the outside looking in. Another clue comes when we look at other galaxies. For instance, this is the galaxy called NGC 891, and this is somebody else's galaxy. This is a picture taken through a telescope. But notice the shape. You have a broad center to it, a fairly bright bulge in the middle, and then tapering off to either sides. So what you can make the conclusion of is that this galaxy right here has the same shape that the Milky Way galaxy has, because it looks the same. And of course, this is a galaxy that is somebody else's galaxy or somewhere else in the universe, and its shape could reveal the shape of our galaxy. So it starts to give us some clues as to what our galaxy would look like if we could see it from the outside. And again, we'll come back to more of that in just a minute. When we start to look around the galaxy and try to figure out what it's made out of, we start to pull together some of the topics from previous videos. We've talked about how the space between the stars, the interstellar space, is essentially filled with two different types of matter, gas and dust. And if you recall, the gas is mostly hydrogen with a little bit of helium and trace amounts of other things. And remember, the hydrogen is revealed by the color that it emits. The emission of this color that you see here is unique to hydrogen. So these are hydrogen clouds. And in this image here, you can see the dust clouds. So if you remember, interstellar dust is something that is essentially very tiny particles of carbon and oxygen and silicon and so forth. And remember, the dust blocks the light from behind it. That allows us to see the silhouette of the dust. So in the Milky Way, you have vast collections of clouds of gas as well as clouds of dust, as well as the stars themselves. And it is these clouds of gas and dust where star formation is actively happening in our galaxy as we speak. The other thing is the astronomers of the 19th and early 20th century started to dig a little deeper. One of the questions is, what is the location of the sun inside of the Milky Way galaxy? So if we establish that the Milky Way galaxy has a shape sort of like you see here, matching what we see in the sky, what we of course want to know is where is the location of the sun inside of this particular object. We know we are inside of it. It wraps all the way around us, but that's a little bit difficult to get any deeper than that when it comes to our exact location. One of the things that started this concept is to assume that we are at the middle of our galaxy. Well, you can't assume anything in science. You have to prove answers to questions. So there was a better way of doing this that involved the location of a particular type of cluster that surrounds the Milky Way galaxy. Each of these little tiny white dots represents a type of a cluster called a globular cluster. And if we could see what these look like up close through a telescope, this is two examples you see down here. A globular cluster is a vast collection of many, many stars that are gravitationally held together as a group or as a cluster of stars. This example here is a very famous one called M13, and it has about 250,000 stars all together that are essentially one single grouping of stars called a globular cluster. This globular cluster over here is one of the biggest known to astronomers. It's called Omega Centauri, and it's a globular cluster that has probably 2 million stars all together as this one single group. It's a massive cluster of stars. Now, these globular clusters surround the Milky Way, above it and below it, and you can see the way that they're distributed. They are all distributed around the galaxy as if they're concentrated at the middle of the galaxy, as if the galaxy itself is keeping them centered on the galaxy's own center. And this is due to gravity. Each of these clusters is moving. So an example is M13 over a long period of time would move like the arrow or the cursor. It would go around the galaxy and come all the way back down again. And it's just gravity that causes all of their movements to be centered on the center of mass of our galaxy. Now, there was an astronomer in the early part of the 20th century. His name was Harlow Shapley. In 1914, he came up with an ingenious way to figure out where we are located in the Milky Way galaxy. Here's the logic that he came up with. He said, if we are at the center of the Milky Way galaxy, then when we go outside and look in the sky and find the globular clusters, we should see them all around us, because if we are at the center, then the location of these clusters should also be all around us equally, because we would also be at the center of the distribution of these clusters. However, if the sun was out here in the disk of the galaxy, not at the center, not at the edge, what we would find is when you look in one direction in the sky, you should see a lot of globular clusters, and when you look in a different direction in the sky, you should see fewer of them. So if you find that the clusters are not equally distributed all the way around us, then we can't be at the middle, we must be somewhere out in the disk. So in 1914, he used the largest telescope in the world, which was the 60-inch telescope at Mount Wilson Observatory. And what he did was he plotted the locations of all of the globular clusters. Essentially, he mapped them out, their distances and their locations on the sky. And what he discovered is that when you find all of the globular clusters, and there are about 150 of them that surround the Milky Way, in the sky, you find that they seem to be concentrated towards the constellation of Sagittarius. They're all over the place, but there's a fair high amount, let's say a fair concentration, a high number of them in the direction of Sagittarius. So the answer is there are more of them in one direction than any other direction, which means we must be out in the disk, not at the center of our galaxy. The center of the Milky Way galaxy is in the direction of the constellation of Sagittarius, and by plotting the locations of each of these clusters in a three-dimensional manner, he was able to figure out that the sun is located about 28,000 light years away from the center of the galaxy. So what we now know is that the sun's location in the Milky Way is not at its center, it's not actually at its edge, edge, but it's about 2/3 of the way out from the center of our galaxy, about 28,000 light years out. If you could travel at the speed of light, and you could do it for 28,000 years in the direction of Sagittarius, you would reach the center of our galaxy. Now in the next video, we're going to continue trying to explore the shape and the size of our galaxy, as well as some of the details of why its shape is what it is. I hope you'll join me.